Okay, let's have a look at this question today. This is a question about perfect number. Prove some number is a perfect number. So before we start to proving these questions, we have to understanding what is a perfect number means. So what is a perfect number? Perfect number is the number equals to its sum of its factors, but excluding the number itself. So say for example, I give you a number 6. So I'm going to list that all the factor of 6, okay? So the factor of 6 can have 1 and 6, but of course 6 we can't list in here because it's excluding the number itself, so 1. And the next one would be 2 and 3. I think that's all. And then we're gonna plus them together and it actually equal to 6. So therefore 6 is a perfect number. And then maybe we get another number 28. So 28 can have a factor of 1, of course, but it can't have 28, right? Because 28 is its number itself. And it can have 2 and 14. And it can have 4 and 7. And I think that's all the factor you can have, except for we can't write a 28. So now let's plus them together. So we do 1 plus 2 plus 4 plus 7 plus 14 is actually equal to 28. So therefore 28 is our perfect numbers. So this is how we tell the number is perfect number or not. Okay, so now let's prove this question. So the question here, we prove if 2 to the power of n minus 1 is prime number, then 2 to the power of n minus 1 times 2 to the power of n minus 1 is a perfect number. So how do we prove these questions? So we write this number down. So 2 to the power of n minus 1, 2 to the power of n minus 1. So this is the number. So I'm going to list out all the factors for this number. So first one, I'm going to do 2 to the power of 0, which is 1 anyway, 2 to the power of 0. And another one would be 2 to the power of n minus 1 with 2 to the power of n minus 1. But I can't list this number because this is the number itself. So that's not included. Okay, and then move on. The next one, I'm going to write all the factors. One is 2 to the power of 1. And the left would be 2 to the power of n minus 2 with 2 to the power of n minus 1 is another factors. And the next one would be 2 to the power of 2. And here would be 2 to the power of n minus 3. And the 2 to the power of n minus 1 is another factor. And keep going. And then the last one would be 2 to the power of n minus 1. And here would be just 2 to the power of n minus 1. So both left column and the right column, they're all the factors of this number. And I didn't do any factors from 2 to the power of n minus 1 because the questions give us 2 to the power of n minus 1 is prime numbers. So it doesn't have any other factors other than 1 and itself. So there's no other factors I need to write it down for this part of the factors. So that's all the factors I have for this number. So I'm going to plus them and to see if it's equal to the number itself. So the first half of the factors is this part. I'm going to highlight it into different colors. Let's say into the blue. Okay. So this column is actually a geometry progressions. And the second column, I'm maybe using the yellows. Okay, maybe the green would be better. Okay, the greens. So only these parts. So 2 parts. Okay, let's just do the blue part first. So the blue part. So it's a GP. So we know the GP sum formulas is A R to the power of n minus 1 R minus 1. So for this one, the first term is 2 to the power of 0, which is 1. So equals to 1 times, and the common ratio is 2. 2 to the power of, and how many terms? From 2 to the power of 0 to 2 to the power of n minus 1, so there will be n terms. So minus 1 and over 2 minus 1, which equals to just 2 to the power of n minus 1. So that's the blue parts. Now let's do the green parts. So the green parts here. So this series, they all have 2 to the power of n minus 1. So I'm going to take in these as common factors. 2 to the power of n minus 1. The minus 1 is the bigger one. I wrote it wrong. So 2 to the power of n minus 1 here like that. And the left with another GP, which is starting from 2 to the power of 0, 2 to the power of 1, until the last one would be 2 to the power of n minus 2, the last one. So then I bring it together. I'm going to use the GP formula again for the second half of the series. So the first term is 1, because 2 to the power of 1 is 2 to the power of 0 is 1. And the common ratio is 2. And then from 0 to n minus 2, there's n minus 1 terms. So I put in the formulas, 2 minus 1. So this half will give me 2 to the power of n minus 1, and with 2 to the power of n minus 1 minus 1. So this is the blue section, or green sections of the sum of the factors. So I'm going to adding the blue and the green together, finding the total sum of all the factors. So it becomes 2 to the power of n minus 1 plus 2 to the power of n minus 1 with 2 to the power of n minus 1 minus 1. So I'm going to take in the common factors with 2 to the power of n minus 1 as common factors, and then leave me with 1 plus 2 to the power of n minus 1 minus 1. And then I do one more step, 2 to the power of n minus 1 times 2 to the power of n minus 1. That's actually equals to the number itself to starting with, which is here. So therefore, this number is a perfect number.